Okay friends, now I will solve an example about charge. It says that typical lightning bolt has about 10 coulomb of charge. How many excess electrons are in a typical lightning bolt? Total charge is given, Q is given, and it is equal to 10 coulomb. Then number of electron wanted, and we know charge of an electron here, minus 1.6 10 to the power of 19 coulomb. So total charge, calculation of total charge is equal to n multiplied charge of an electron. Here n wanted, n is equal to Q divided by charge of an electron. Then n is equal to here 10 coulomb divided by 1.6 10 to the power of 19. I use just the magnitude of electron, I don't use sign of it. N is equal to, if you use calculator, you will see that 625 10 to the power of 19 electron. So during a lightning, that amount of electron flow through the earth. The second question is, it is about electrostatic force, electric force here. It says a balloon rubbed against a denim and it gains a charge of minus 8 microcoulomb. Charge of balloon is given, let's say Q1 minus 8 microcoulomb. I have to change it because microcoulomb is not SI unit, and it is equal to minus 8 10 to the power of minus 6 coulomb. And then the second, if the balloon gains this charge, means that the denim will gain same charge but opposite of it. Q2 will be plus 8 microcoulomb, and it is equal to plus 8 multiply 10 to the power of minus 6 coulomb. And the distance between them 5 centimeters. In our book, distance is used as R, and the symbol 5 centimeters. In order to find meter, we will divide it by 100, so it will be 5 10 to the minus 2 meter. What is wanted? Force wanted, F electric force. We know F electric force is equal to K multiply Q1 multiply Q2 divided by square of distance between them, R square. Then F is equal to, K is 9 10 to the 9 is constant. Q1 is 8 10 to the power of 6 minus 6. And Q2 again 8 10 to the power of minus 6. As I say here, during calculation, we just use the magnitude of charge. Distance 5 10 to the minus 2 and square of it. Then F is equal to, if you use calculator, you will see that F is equal to 330 Newton. That is the force between two charge. Okay, let's pass another. Now third one is, second question, second A, it has two parts, A and B. Say two identical conducting spheres, identical means same size, placed at a distance of 30 meters, 0.3 meters apart, one charge 12, 10 to the minus 9, and the second minus 18, 10 to the minus 9. Again the charges are given. Q1 is equal to 12, 10 to the minus 9 coulomb. Q2 is also given, it is minus 18, 10 to the power of minus 9 coulomb. Distance between them is given, R is equal to 0.3 meters. The force between them wanted, electric force between them wanted. So let's calculate it. F is equal to K multiply Q1 multiply Q2 over R square. Then F is equal to K is, electric constant, coulomb constant, 9 10 to the 9. Multiply Q1 is here 12 10 to the minus 9 coulomb, and multiply the other charge also 18 10 to the minus 9 coulomb. I will repeat it again. We don't use their sign during the calculation because here we calculate the magnitude of force, electric force, over square of 3 distance and 0.3, square of 0.3. Then F is equal to, as I say, use your calculators and you will see that the force between them will be 2.16 10 to the power of minus 5 Newton. Yes. Let's see part B part of it, second question. They say the spheres are connected by a conducting wire after equilibrium. Of course, these are different. They have different charges, and then the charge will move from one to another. After equilibrium, what is the electrostatic force? It says. So when they touch to each other, Q net will be the addition of these two spheres, charge addition of the charges, Q1 and Q2. Q net will be here, 12 10 to the power of 9 plus the second charge is negative, 18 10 to the minus 9 coulomb. So when we get it, the excess charge or the net charge will be minus 6 10 to the power of 19 coulomb. And the two spheres will share it. Spheres will share this charge. So Q1 prime, after touching we can say prime, Q1 will be minus 3 10 to the power of 9 coulomb, and Q2 will be minus 3 again 10 to the minus 9 coulomb. Now we know the charges. The distance between them does not change. R between them was 0.3 meters. So F wanted now after touching them to each other. F is equal to K Q1 Q2 over R squared. Then F is equal to 9 10 to the 9 multiply Q1 is 3 10 to the minus 6. Minus 9, 10 to the minus 9, multiply, again 3, 10 to the minus 9, divided by square of 0.3. And when we calculate it, we will get force as 9, 10 to the power of minus 7 Newton, 9, 10 to the power of minus 7 Newton. That is the force between them after touching. It is a repulsion force because Q1 and Q2 are minus, negative. Third one, there are two charges and distance between them wanted. The force is given. Q1 is equal to 60 microcoulomb. Let's change it to coulomb. 60 10 to the power of minus 6 coulomb. And Q2 is equal to 50 microcoulomb. And again it is equal to 50 multiplied 10 to the power of minus 6 coulomb. And the force between them is given. Force is 175 Newton. It says, so what is the distance between them? Electric force is equal to K multiply Q1 multiply Q2 over R squared. Then when we cross multiply, it will be like this. R squared is equal to K multiply Q1 multiply Q2 over R squared. If I take the root of each side, then R is equal to in root K multiply Q1 multiply Q2 over F. Let's put their values, their places. We know K 9 10 to the 9. And we know Q1 is 60 10 to the power of minus 6. And then Q2 50 10 to the power of minus 6 coulomb. Divided by the force between them, 175. And you calculate it, use your calculators, you will see that R is equal to 0.39 meters.